Hey everyone, welcome back to class. In this lecture, we're going to be talking about levels of measurement. This is building on our understanding of operationalization and how we measure the concepts in our research design and in our hypotheses. And so we're going to be moving on to kind of give you guys some tangible, workable key terms to understand what's happening in a data set when I give you one in the context of this class. And when you move on to produce your own research, you have a foundation for understanding how researchers have measured their concepts. So let's get into levels of measurement. This is all about classifying data. So we're talking about levels of measurement. We're talking about how we classify our data, create details about the data, and create information about the observations that we care about. So it's clarifying the kinds and categories that are in our data, and also deals with how detailed our variables are and how detailed our measurement is. So levels of measurement specifically are a way of classifying and a classification system that allows us to describe how much detail is contained in each measurement. There are two main kind of concepts that we can look to talk about the different kinds of measurement. You either have categories, which are boxes that you can place your observations into, or you have scales and indices. So within categories and the boxes you can place your observation into, that can look like things like, say I have a variable that I want to measure, which is what kind of car my students have. So in that example, with the variable being car kinds, I would then record and ask whether or not, or what kind of car students have, and they'd say Ford, Mitsubishi, Mazda, Subaru, Toyota, and these are all different categories of car makers. And they're boxes that each of my observations fall into. You could say the same thing for fruit types, favorite fruit, mango, papaya, strawberries, blueberries, all of these things are different categories. You could also do the same thing for genders, man, woman, non-binary, all of these things are different boxes. It's less detailed, but still vitally informative as social scientists. We also have the other kind of broad category of scales and indices as a kind of observation. And these are numeric values or tallies of details and observations. They're counts of phenomena or events. So they're numeric in nature. They're going to be more detailed because of that. Examples can be how much everybody's pets weigh, midterm scores, or literacy rates, like percentages of the amount of people that can read in a given country, right? So we've got categories and scales and indices at the broadest level. So there are three different specific levels of measurement that I want you guys to learn in the context of this class, and one special case. So these categories are either nominal or ordinal, or a special case of this is called binary. We'll talk about the details of this shortly. And then for scales and indices, they're called interval ratio variables. So the category broad umbrella has two different kinds, nominal and ordinal, with the special case of binary. Scales and indices, they're called interval ratio. So we're going to use the example of the voting data set that we've already looked at. We'll have four different variables. One is voter name, one's race and ethnicity, one's whether they voted in the 2018 election, and the last one is how many rallies they went to in 2016. So nominal variables in this sort of category bracket is the type, this type is measured in categories, and the defining features that they're non-ranked and non-ordered, right? So it's the most generic box that we could put somebody in, right? Car type was a good example of this. Gender, race, marital status, or major are also good examples of this. So this is the first little bit of R code that you're going to see in the context of this class. It's using this, this is kind of sitting within this cable package and this cable function where we're selecting out certain variables in this voting data set. And I specify which variables and how many of those observations I want to pull. This is going to sound a little confusing now, but you're going to have some good command of this later on in the quarter. But I'm selecting out the race and ethnicity variable that we saw here, right? And within this, there are four different categorizations of race, right? So this is a nominal variable where race is operationalized as four different categories. One is white, two is Latinx, three is African American, and four is, say, indigenous, right? So for the first two rows, those people are indigenous, right? Because we've classified them as 4. The next 3 rows are going to be classified as white because they were given a 1. And the same for the next 2 for indigenous. And that third one is going to be African-American, I think I said. But essentially what we're saying is that we can numerically assign race a category, and this is a common way of coding race. It's nominal because we can't rank or order something like race or gender. They're just boxes we can put somebody in, right? So this is a very common way for social scientists, political scientists to measure race in their surveys and in their data sets. So this kind of conception of race you'll continue to see moving forward. Ordinal is the next one in this bracket of category type measurement. So they are still measured in categories, but they're rankable or ordered. So a good example of this is party identification, right? Because we can put it on a left to right continuum. We can operationalize it between 1 and 7. So these are like the strength to which somebody fits on this left to right spectrum. So they're rankable and they're ordered, but there's not inherent value differences between. Income categories are another way to think about this, and class standing, whether you're first in the class or 30th in the class, there's meaning between the two, and they can be ranked or ordered, but there's not meaningful differences between those ranks numerically. It's just that they're rankable or ordered. This is probably one of the more confusing ones. The last example is binary, right? So this is a special case when you operationalize these categories. There's only a 0 or a 1. And if it has that aspect that you're looking for, you give it a 1. And if it doesn't, you give it a 0, right? So I'm looking at that voting data set and I'm pulling out this variable that's binary called voted 2018. If somebody checked that they voted in 2018, I give them a 1. If they did not vote in 2018, I give them a 0. So let's recap this. Nominal or unordered descriptions, right? So an example of this is I'm a turtle, I'm a snail, I'm a butterfly. There are all these different species. There's not any ranking. We're not asking people's favorite animals. They're just different categories, different boxes we can put people into, or species, critters into. A good example of ordinal or ordered descriptions are this kind of little bee visualization. I'm unhappy, I am okay, I am awesome. So it's increasing in levels of excitement or happiness. There's not a numeric difference, but it is rankable. Lastly, is this kind of binary special case where there's only 2 mutually exclusive outcomes, a 0 or a 1. And the dinosaur says, I am extinct. And the shark says, ha, I'm not extinct, right? So if you're extinct, you get a 1. If you're not extinct, you get a 0. So you can return to this as kind of a quick, easy way to talk about ordinal, nominal, and binary. So moving on to interval ratio, right? So there's a defined difference between these values. And there's 2 different ways to talk about this, either continuous or discrete. Good examples of this are temperature, GDP, percentages, test scores, and numbers of events. So in this particular example, we're talking about our rally in 2016 variable from the voting data set. And this is the number of how many rallies somebody went to. And the first observation, that first person went to 3, the last person went to 1. So there's a numeric difference between all of them. And there's a defined difference between the values that's meaningful. It's not just ranked or ordered, but it has numeric meaning. So a good way to think about the difference between interval ratio and ordered is one of them's dealing with categories, the other one's dealing with an actual kind of number difference. So to explain the difference between continuous and discrete, right? So this is less of a recap, more of some new terminology. When you have these sort of numerical values, they can either be discrete, like this one is, right? So it's you can only go to whole numbers of rallies. You can't go to half of a rally. So you can only put 1, 2, 3, 4, 5. I cannot put 2.5. I cannot put 5.6. That is discrete. There's a set. The observations can only exist at limited values, often specific whole counts. So a good example of this is the octopus that says, I have 8 legs and 4 spots. There's not a half a spot or a half a leg, right? Only limited, often whole counts. Continuous, on the other hand, is something like in our last example, maybe GDP, test scores, if you can get half a point. They're measured data that can have an infinite number of values within a possible range. And so a good example of this is like weighing a little baby chick, right? That chick is 3.1 inches tall and they weigh 34.16 grams, right? So just think about the fact that we can have partial values in continuous and discrete we cannot. So the key terms I want you guys to take away from this is that there are 2 kind of broad conceptions of levels of measurement, either categories and scales and indices. Within categories, you can either be nominal or ordinal with a special instance of binary. And with scale and indices, you can just be interval and ratio. And within that numerical kind of conception, you can either be continuous or discrete. That's the best way to think about these. And these are going to be super important for you moving forward, especially when we start to do our own statistical analysis, because when we do that, we have to know the level of measurement in order to use the appropriate tools.